Hey everybody, my name's Josh and welcome to the greenhouse. So in here we have Dr. Jabali's bromeliad research collection, and these plants, there are 3 species and they've been growing for the past 4 years in this greenhouse. And throughout those 4 years we have been collecting a lot of morphological data on the growth of these plants. And recently, in the past year, some of them have started to flower. So my thesis specifically focuses on these 2 plants, which are both in the bromeliad family, but are in separate subfamilies. So this plant is Bilbergia brasiliensis, which is in the subfamily Bromelioideae, and this one is Vriesia raphaelii, which is in the family Tillandsioideae. These 2 plants are perfect because they vary very much differently in floral traits as well as a little bit in morphology. But these plants are native to the Brazilian Atlantic rainforest, which is on the eastern coast of Brazil, and both are epiphytes. And while there's not much known about both of these species, Vriesia is assumed to be pollinated by bats. It opens the flowers at night, nocturnal anthesis, and Bilbergia is assumed to be pollinated by hummingbirds. And while they differ in pollinators, they also differ in the type of fruits produced. So Bilbergia produces these fleshy fruits, and Vriesia, which has capsule fruits with the seeds being dispersed by the wind. So to start with Vriesia, I first check for pups to see what the number of pups per individual there are. I would measure the mom longest leaf length and then also the pup longest leaf length if there is a pup on the individual. From there, I'll move on to collecting some data on the floral parts. So both Vriesia and Bilbergia are self-compatible species, meaning that their anthers are close to the stigma, allowing for self-pollination of a certain flower. And so on this specific individual, we see a few flowers that have already opened, and because of that close proximity of those reproductive parts, we would expect those flowers to have self-pollinated themselves. When I come to the greenhouse, I come around the anthesis timing for Vriesia. I'll look for those flowers that are starting to open, and then from there, I would want to emasculate the flowers, meaning I would take the stamen out of the flowers so that I can perform a cross without the risk of that plant self-pollinating itself. If the anthers have not dehisced, which they usually have not around right after opening, the flower opening, I would go in and remove the whole stamen. So I would grab the filament and the anther, and usually I like to keep the anthers and freeze them just in case if I need pollen for another cross. And then I wait a few hours, so I come back around 10 o'clock p.m. and then that's when I would perform the cross, because usually the anthers have already dehisced at that time and the stigma is receptive. The way I check for stigma receptivity is with a hand lens as well, and then the stigma kind of looks very moist and wet on the tip. So then I know it is receptive to pollen. And before I perform the cross, I collect nectar. So I use these little mini pipettes, go into the base of the flower where the nectaries are, and collect all of the nectar that is in the flower. There is a lot of nectar in these flowers, and from there I would place it on the refractometer. After placing it on the refractometer, I hold it up to some source of light to look into this refractometer, which will tell me the concentration of sugar in the nectar of that flower. So I'll hold it up to the light, and for this flower, The sucrose concentration is looking around 12.2%. So for my thesis, I'm really looking to see if there is any difference in reproductive effort in flowers that were outcrossed versus flowers that were selfed. And so the first part of my thesis experiment was doing the crosses themselves. And then we got to let the fruits develop. So flash forward about 6 or so months, then the fruits are developed. And from there, I am going to kind of quantify that by looking at the weight of the fruit altogether, the mass, as well as the mass of the seeds in the fruit. And so on this specific individual of Rhesia, you can see that there's some difference in the fruit size, and I'm curious to know if that is due to differences in flowers that were outcrossed versus ones that were selfed. So when I was doing the crosses on Bilbergia, the flowering pattern is a little bit different. So on this individual and all the individuals, they open up all the flowers at the same time. So to avoid any cross-pollination of the ones that I wanted to make sure were only selfing, I used these cute little wedding bags, and I placed them on the flowers to make sure that pollen landing on the stigma was only from that specific flower and not coming from a different flower on the same individual. So now that the individual has started to develop fruits, let's bring this down to the lab and quantify reproductive success by massing both the inflorescence structure as well as individual fruits. So once in the lab, I start by dissecting the fruits, and during this process, I masked the fruits both wet and dry. But because a lot of that wet mass can be attributed to water, which has a lot of variability with when you last watered the plant and location, we really care about the dry mass. But my first step is I will grab the fruit off the inflorescence, give it a nice little twist. From there, I measure the width of the fruit at its widest point, as well as the length from the base of the carpel to the tip of the carpel. And then after I've gotten both measurements, the width and the length, it's time to dissect. I start with just one cut down the middle of the fruit, and luckily I have tools that are very specialized. This pimple popping kit from Amazon does the job wonderfully. I like to separate the seeds from the rest of the structure, and we like to mask these on this analytical balance. So to start, you always want to make sure you tear the balance with the weigh boat on it. And then from there, I'm going to remove the seeds, which in Bilbergia are very sticky and gooey, which lends itself to a very fun time in the lab. So after I have removed all of the fruits from the inflorescence, to make sure that we're accounting for all of the resources and energy that that plant has put towards reproductive structures, we cut down the inflorescence all the way down to the base and dry that. So after wet massing the fruits, then I would bring them up to the dryer, place them in here, which is a nice and toasty 70 degrees Celsius. We'll let them stay in here for about 4 days, and then I'll bring them back down to the lab and do the final dry mass.